Greetings and welcome to this installment of Introduction to Solid Modeling using SolidWorks. And we've been using the tool room as our guide. So far we've made a saw and we've made a screwdriver with multiple bits. And as you can tell, this is the crescent wrench. Well, this is just the handle of the crescent wrench. And this is our next project. If you're wondering if it's a little bit more complicated than the other ones, you are right. We have about 20 to 30 features here, some of which you are familiar with and some that might be new. So just to give you an overview of where we're going with this, I'm going to grab this little blue line here, and we're going to start off, of course, with simply our front, top, and right planes. And of course they intersect at the origin. So we're going to use those heavily, and we're going to make a good decision as to where we start our first feature and why we start our first feature this way. Then we're going to use something called a draft to narrow the first feature from bottom to top. We're going to make some datums, a datum point right about there, and a plane. Right click on that and click show, and now we can show where that plane's going through. And then a cut revolve. And it's just a very thin slice like this. And it's based on all of these. And then we mirror the cut revolve. So there's the original, and there's the mirror. Then we make an axis. And then we're going to make a series of planes. There's one. There's another. There's another. With these are going to come some sketches. This one, that one, and that one. And strangely enough, this is probably bad form, but I created the handle section all on its own out here because I wanted something to drive towards with our loft. Cut it there. On the opposite side. There we go. And then I mirrored that cut on the other side. So I had the top fairly well established and the handle, and now created the loft to connect the two. Drove in a couple fillets around the handle, then finished up the detailing of the head. Also put in different sized fillets in that area. Then cut this section all the way through. Then put in that notch there. Then put that hole in there. And finally made a tapped hole using Hole Wizard at the very end. So let's get started. Now, one of the first things I want to show you is not how to model anything at all, is first make sure that you are using the correct units. So many students miss this step so early, and then they have to rework it, and it's pretty painful. The second is up here, make sure that you always have this set of tools open. It's one of the first things I do if I am encountering a file that does not have these open. I just hit that little push pin and it keeps it up. The third thing is to click on this options button. This will bring up a bunch of things that you can change in your entire document. So for the system, you can see a variety of things that are selectable or not. We've got display styles, fills, colors, and so on. There's so many different things. You should take some time to go through them and see what they do and see what good they are. But most of the time we'll go to document properties. And I have this set as a default on my system. Very often you'll see ISO as the drafting standard. I prefer ANSI. It just makes sense to me, not just because I've used it, but I've looked at it and it just makes more sense. Now the dimensions, if you go to dimensions, you can set all the different sizes and offsets and styles and displays and so on that will define and make your drawings and models look one way or another. Most of the time you don't want to mess with that because it's part of the ANSI drafting standard, but from time to time it makes sense. A couple places you might want to set are angles and some of the other dimensions. For example, the precision. Maybe a particular part you're using is fairly large and you're going to have fairly low precision, so only 1 decimal place, but you might be doing something very small or that really needs 3 decimal places, and so it may make sense for you to set that early on so that you don't have to keep going back and changing that or wondering if someone's going to pick up on your 2 decimal place that you mean to have 3 decimal places. Of course, 4 decimal places and beyond when it comes to inches is usually pretty expensive, so you have to make sure that you're using the right number of decimal places and precision for your application. So there are many other things that you can set here depending on your materials. Maybe you're using sheet metal and so on. But that's the number one thing we're going to be considering, is dimensions and annotation using specifically the ANSI standard. So that again is going up here to options. Click here, you can go options, you can customize, you can put some other things there if you want to. Okay, now that we have everything set up for our document, for the crescent wrench, you go back here, and I struggled with the decision of where to put the planes and where to put the origin. So I reasoned it this way. I can look at it pretty much one of 2 ways. Either A, base everything from the handle and work up, or B, base everything on the head here and work down. My thought was that there's more detail here in the head than there is in the handle, and to turn a corner and change angles would be easier to do that with the simple stuff than to build the simple stuff and then turn a corner and build everything up here off of some angled plane. So between that and noticing that these 2 surfaces right here and here mate with other surfaces on the other parts, and they're at right angles, and they're part of the more complex geometry, that made my decision fairly easy. So I chose to use these 2 surfaces as my right and top planes. Now this starting sketch can be a little crazy here. So I'm going to start with front plane here. I'm going to go to sketch. And then I'm also going to show, right click on the glasses, going to show my right and top planes. I'm going to use them. I'm going to start up here, come here. go out and then back in. Make that curve out here, down here, over, up. Okay, now this curve on my original handle is not actually tangent, so I don't want to go back here and do this because it'll make a tangent. Now these curves are not tangent here, so doing the tangent shortcut won't help us. So I'm going to make, instead of a center point arc, I'm going to make a 3-point arc here. Yeah, I didn't like that, so I'm going to delete that. I'll just click back up here, go from here, here, something like that, and then I'm got another one here, goes up here, and then down like that. Now these two are supposed to be tangent at this point, so I'm just going to grab this and try to make it work. You can just click and drag these things, and click here, click that, make them tangent, grab this point, maybe bring it up here. Okay, so I've got the basic idea of this sketch, and based on my measurements, they're going to fall into place like this. Okay, we'll go to Smart Dimension, make this 0.125, going from here to here. Oh, the very point up here is going to be 1.06. Uh-oh, that's trouble. And so we already have some serious problems. Well, I will try to mend this around. May not work out too well here. So I might have to just delete some of these curves and put them in later. So I'm going to go back to Smart Dimension, go from here to here, make it 1.06. Okay, I'm going to go from here to here, make it 1.63. Notice how I continue to try to select lines as best I can. If I want to make a horizontal dimension, I grab a vertical line, and then I can grab a point or center of an arc or something like that after that. Okay, from here down to here, notice trying to do a line down to a line. Hopefully they're both parallel, because then I'll get a linear dimension. If they're not parallel, you'll end up with a angle, and then you have to make sure that they're parallel first and then redo the dimension. Speaking of an angle, here we go. It's supposed to be 21 degrees. This angle here is 44. And this dimension from this point down to this line, again, is supposed to be 0.2. Now I'm going to try those curves again. Here, here, something like that. And then try this one here, this up here, and it looks almost tangent there. So hit escape, and my dimensions are as follows. This is going to be 0.8. This is going to be 1.5. Well, I never made this point go up to the top there. Oh, where did you go? There it is. Okay. And these two are supposed to be tangent. Okay. Another dimension going from here all the way over to this point. Now, it's going to the center here. Notice how I can put it right here, and it's actually going to give me that slanted dimension. If I go up here, it gives me a horizontal one. Could even maybe get it to, oh, there's a vertical dimension here that I don't want. So I'm going to make sure this is horizontally associated here. I'm just going to hit green check mark. I want this leader to go to the maximum condition, and then I change it to 2.2. Should bring things in. Now it's starting to look a little bit better. I noticed that when I zoomed in, I did not get what I wanted over here, so I need this and this to be tangent. Oh, that's much better. Now that's black. Okay, now looks like we have just about everything in place, and it's looking pretty good. The only problem is that these are still blue. It doesn't quite know where these are. It can still grab this. Wants to be on that point. I think here's, oh yeah, it's not quite sure where these 2 points are. This one and this one. Now, what I decided to do was make a center line that comes straight off of this point here. Okay. And then I'm going to make this, hold the control key down, tangent to that curve. Of course, it'll be tangent right at that point. Then I'm going to make a dimension going from there to there, and it's going to be 53 degrees. And notice how everything else turns black. So I hit escape. I'm going to move this R80 out there so it's easier to understand. Yeah, R13 is looking good. Everything seems to be all set, and I'm happy with my sketch. Going to save this, and when my sketch 1 is selected here, I'm going to go to Features, Extruded Boss Base. Now, since my sketch was already selected, it automatically went to that sketch and assumed that I wanted to extrude that sketch. In this case, for my measurements, I'm going to make this 0.582 deep, but since this is a symmetric part, I want to make this go mid-plane. I want this to go right down the middle of our front plane this time. So I'm going to go to blind, click instead mid-plane, and that helps out. This is what we really want. And there we have it. And notice how I kept it with the right plane here, the top plane here. That makes a whole lot of sense for the orientation of the entire model. My next step is to make the draft. Notice how as we look straight down, this is straight up here as well. Well, for many different types of parts, especially those that are cast or injection molded, they will want to have a draft on them so they are easily removed from the mold. If you have something like this that has straight lines, it's very difficult, if not impossible, to remove it from a mold, or at least do it without damage to the part. In this case, it's not exactly why we're making a draft. It may come from a mold, it may not, but it will be just the right feature to use in this situation. So I measured it, and it's approximately 5 degrees on each side. So we'll go to draft, and I'm going to make this 5 degrees. They have this draft expert thing. I'm going to go to manual instead, and I'm going to use a neutral plane. The neutral plane is the plane at which your dimensions are original the same, so it's going to fold in from that neutral plane. And the faces I want to draft are this one here and that one there. And click your green check mark, and uh-oh, it did the draft the wrong way. It's doing it out this way instead of in. Now, we just right click on that, we edit the feature, and we reverse the direction. Hit your green check mark, and now if you look at it, they actually kind of point inward. If you'll notice, they do point inward, but this doesn't look like 5 degrees to me. So we're going to go back to the draft, right click on that, and for some odd reason it's stuck with 1 degree. So I'm going to hit 5, make sure it stays that way, then hit our green check mark. Aha! Now that looks more like my 5 degree draft. Okay, my next step is to try to make this surface here a little more realistic. Now, I could have skipped this, but it should be an interesting challenge to work with. I decided that I wanted to make a revolved cut, but I needed to make up some geometry first. Now, this curve has a 1.5 radius surface here and a 0.8 radius surface here. So if this kept going, it would kind of come out into space over this way. So I decided that I would try to keep that going just on this surface, which is kind of how the actual part looks. So I'm going to first have to find the center of this 1.5 radius. So I'm going to go back into Sketch 1 and I'm going to make simply a point. So I'm going to make a feature, reference geometry, point, and I'm going to look at that sketch. I'm going to right click on it and I'm going to show it, and I can see that right here is my point of that 1.5 radius. So I'm just going to click right there, green check mark, and I have made my point. Now I also want a sketch plane on which to make my revolved cut. So I'm going to make a reference geometry plane that's going to go through that point. I've already selected that. And where else is it going to go through? Well, right here. It's got a great spot on that edge. So that edge plus that point determine a plane on which I'm going to make a cut. So here I had to do some guesstimation, and I'm going to use this plane to make a sketch. I'm going to look straight at that sketch, and all I want to do is make an arc. Now, following along carefully, but I'm also going to make some mistakes, but kind of on purpose. Okay, I'm going to make a center point, and I'm going to use that same point because, hey, I couldn't really measure it all that well, so it was close enough to that 1.5, so I'll just keep that 1.5 dimension as my radius. So that point right there is 1.5 away from here, so I don't even have to put the 1.5 in there. Now, here's something that gets a little bit annoying. Now, as I've mentioned before, it's good form to put in a full loop. So that's what I'm going to do here, and I should have deleted this, so I'm just going to delete that, and I'm going to put this arc in from one side to the other. Here, oh, there we go, all the way over to here. Bring this out from this edge. Okay, and then click these two, drag this down to here, make sure they're together. I'm going to make this collinear. I'm going to make this and this one and this one tangent. Make sure that this goes through that point, that and that collinear as well. that has to go onto this line, make those collinear, and voila, it is all black. No dimensions needed. The only dimension I would have needed, again, is that 1.5, but since I'm using the center of this curve as 0.1, and I'm using that also for the center of this curve, it knows where everything is as long as it comes right up to that edge. So, like I said, it's good form to have one path that an ant can go on. But if you'll notice, I actually go against that right here when I make them tangent and they run into each other. The computer's not going to like that. So there's my sketch, and now I'm going to make a feature out of it. I'm going to make a revolved cut. Oh, I forgot to make the axis of revolution, so I'm going to click that, and right click on sketch 2, go up here to edit sketch. In fact, that's always the first thing that you should be making in your revolved cut or revolved boss base sketch is an axis of revolution. So I'm going to go up to here, make center line from here down to here, and it goes right through our point, which is where we want it to go. And now that we've got that, I will click again on sketch 2, go to revolved cut. It automatically picks up this nice center line, which is great. And not sure if I want it to go 360 degrees, but I will go, say, 90 degrees that direction. And on direction 2, I'll go 90 degrees that direction, and that'll be good. But unfortunately, sketch is open, self-intersecting, or intersects the center line. Can't put it on the other side of the center line. It's not open, but it is self-intersecting right at that point. So instead of trying to get around it and make some bad decisions in terms of making dumb dimensions, I'm going to go back into sketch 2, edit it, and I'm going to trim out all of that side of it. Green check mark. And so now I just have one side of it. I'm going to go to sketch 2 again. Extrude. No, I didn't want an extruded cut. I wanted a revolved cut. There we go. Aha, notice how the yellow comes up. That means that it can almost certainly make the cut. But I'm going to do this again, make it on 90 degrees on one side and 90 degrees on the other side. And there we have it. I'm going to start turning off the top plane and the right plane. It's nice to be able to turn these on and off when you need to. As you get more and more features, they will get more and more in the way. So I'm going to turn off that. I'm going to turn off sketch 1, just hide it. And now you can see very easily how that cut made it through. I'm going to use this plane, and hopefully you can see right here the difference that cut makes. See, that's straight here, and then it's actually curved over here, more like the actual part. So now the next step is pretty easy. I'm going to turn off my cut plane there, and then make a mirror of this feature that I just made, cut revolve, and I'm going to do it about the front plane, not the top, because it'll just put it over on the other side. It wouldn't have anything to cut. If I did it to the right plane, something similar, if I went to the top, yeah, it would just cut a little notch over here, maybe, if anything. Wouldn't work out at all. I want the front plane so I can put it on the other side. And there's the yellow preview. There we go. Much better. I'm going to save that. The next thing I'm going to do is set up my planes for my loft. The first thing we're going to do is make a plane that is offset from here by 0.9. Yep, and that's the correct direction, so that's good enough for me. The next thing I'm going to do is make an axis at the juncture of the top plane, and not this one. Get rid of that one, then go to right plane. Okay, these two planes are the ones I want to make the axis at, right down there. That. Then I'm going to make another plane going through that axis, and I want it to be at 22 degrees to the top plane. So I just click here at an angle. The default is perpendicular, which would be 90 degrees, but I'll make that 22 degrees. Oh, I want to flip the offset. That's what I want. So I've got that. And then based on this plane, I'm going to do another plane that is actually 1.5 inches offset. Yep, that's the correct direction, down this way. So you can kind of see where I'm going with this. I've got a surface here. I'm going to make another sketch here, and then I'm going to turn it into the handle at this plane. Okay, my next step is to make these sketches. I'm going to start with plane 2. I'll make a sketch here. I'm going to use a rectangle. And I don't like that. I want to go to the other side here. That's a little better. And I'm going to bring the center rectangle out here. Hit escape. I'm going to make the center of this, make them horizontally aligned. Make a smart dimension from our axis to here, 0.2. Going to have a width of 0.305. Have a length of 1.1. From there, I'm going to exit my sketch. I'm going to make a new sketch. Now, you can also do these lofts just from a straight up surface. I like to make sketches, probably more efficient doing it from a surface, but I'm going to sketch on this surface, and all I'm going to do is convert entities, and it did it. Just converted all those entities, and there's my sketch. Now I'm going to make one more sketch on this plane, and I'm going to make another rectangle. This time just use a corner rectangle. Doesn't matter that much. The point rectangles are nice where it's all centered. They give you the additional lines here, but sometimes I don't want those, so I'll just make sure my line's here. Well, it looks like it's giving me trouble selecting the origin, so it's okay. I've got this. I can click on the origin, hold the control key down, click on my line, and I'll just make the midpoint coincident, so I know that that line's centered right there on the origin. There you go. And then make my dimension of 83 and 0.30. And now I have that. I'm going to work off of this next. Now I thought of a variety of ways of making this handle part of the crescent wrench, and I worked on lofts and a variety of other things, but I settled on this technique. I'm going to make a sketch and I'm going to use the front plane here. I'm going to work off of the sketch that we just made, this one here. So this is sketch 5 right there. So I'm going to make a fairly simple drawing. Here, out, back in, make the curve round, but not going to make it 180 degrees, going to make it a little bit more than that. Then I'm going to come back to this point. So now I don't have to make any dimensions up here. I do have to make this tangent though. I'm also going to make another circle here, then dimension this to be 0.5 radius. Didn't like that. And dimension this diameter to be 0.4. I'll just move this right back to that spot. Actually, I will take that point and this point, and I'm going to make them coincident. I'm going to take that line and I'm going to make them pierce. There we go. So that's what you need to do when these points aren't actually on the same plane. So you can't make them coincident. You have to have a line going through the sketch plane, and this point will go into that line, piercing through that line. Here we were able to make it work. Oh, no, we weren't. So let's try that again. That and that we're going to make pierce. Okay. Now these dimensions look a little bit better, but we need to make another one. I'm going to make a dimension from here, this plane, down to the circle out here, and we're going to accept the default there, but go to our maximum position, and we're going to make that 5.6 inches. Now we still want to make all of this kind of perpendicular to our plane up here. However, these two lines themselves are not parallel because this is a different length than this rounded area here. So what we really want is for the average of these two to be perpendicular. So what we'll do is we'll make a center line going from this point all the way to the midpoint. Let's see if we can see that a little better. All the way to the midpoint there. Oh. Now we made a second line there. There we go. Hit escape. Delete this silly thing. Okay. So now we've got this, which is the average between these two. And yes, they all do this right now, but I'm going to make this line and hold the control key down. This line, going to make them perpendicular. And voila, these all come into black. Now I did not make a sketch line from here to here yet, so you may have wanted to do that first. But there we go. Make sure I didn't do it already. Oh, I do have a line from sketch 5. The sketch 5 itself, line 8. Okay. Okay, so this is the actual line that we just made. These two are from sketch 5 and that's sketch 5. So I'm all set. As one would expect, I've got these two lines from sketch 5, this one here and that one there, and then the one I just made. So we should have 3 lines underneath that. All right, so now I'm done with that sketch, and I can use it to make a basic extruded boss base. And as you can well imagine, we're going to make it mid-plane, and it will just be 0.3 in thickness. Go. And that's what we were hoping for. Now to make the cuts that go into this surface and this surface. Now the difficulty here was that what I would like to do is use the shell command, but that does not do well when you choose two opposite sides. So it became just easier to make a cut of a certain depth and then mirror it. So we'll go to sketch, and we'll go to sketching on this plane, and we'll use offset entities. And this is a cool thing you can do, but it sometimes is a little touchy. So I can do these as offset entities, but I can't do this for whatever reason the computer has. So I have to do that a separate of offset entity. So I click it again, I go here and hit my green check mark, and notice how I've got a circle here and I've got an outline here. And so all that's left is to do what's on this edge here and do another offset entities right there, and we're all set with that. Now we also have to trim this up, so I'll trim these entities here, and also I want to put in radiuses here and here, and I'm going to make them 1/4 inch, and we are all set. Okay, next I will exit my sketch, and then I will use that sketch to make an extruded cut, and my default here. And what I have here is 0.1 inches going blind straight down in. It's fine with me. It's what I was looking for. And that's what I was looking for. To do the other side is quite simple. I'm going to mirror. Pre-selected that cut extrude because I was just selecting it. And I want to use the front plane. And there's the yellow. Preview. That's what we're looking for. Don't need anything else. You can do a full preview to show both of them. And we have both sides. All right. Now we can connect these two with the loft. I had to do these sketches and these planes so that we could at least get to this sketch, and then this sketch gave us this surface and everything else down here, and so now we can do the loft. Now we could have done the loft after we did this sketch here, but I wanted to make sure that all of this was going to look right, and then I was going to do the loft. The loft is more complicated, more computer intensive, so I wanted to make sure all the simple stuff was done first. Now for this loft, all we have to do is select our sketches that we had made, and if I do it in the wrong order here, it might not come up with the right order. So I'll just go to lofted boss base first, then select them in the order that I want them to go in. And we'll go from sketch 4, double click that, sketch 3, and then sketch 5. Now notice how it put the connector points in pretty much all the wrong places. So I'll have to change that around. I'm just going to move this one here. Oh, I didn't move the right spot. I'll move that over here. Oh, still not doing where I want it to go. So I'll just try moving this one instead. move this one twice. And then it comes around there. Ah, much better. And I'll change the start constraint to, well, the start constraint is fine. The end constraint, I want it to go straight in here, nice and tangent. So this curve is nice and tangent to this. So I want it to be normal to the profile. So it changes a little bit, but just about right. There's nothing else that I want to click on here. Green check mark, and that looks pretty good. Okay, much of the hard stuff is done, but the next step is going to be making a couple of fillets. This one we are going to make sure we've got tangent propagation because we want to go here, and this is a little bit too much of a fillet. 0.03 is what we really want. That's better. And we're going to go in here, on the outside there, on the outside there, here. Now all these fillets are important because they can really help in manufacturing the actual part, and they will also reduce stresses in many high stress areas of a part. So the inside there, inside there. And I chose to do them like this and made sure that this area was normal to the profile so that these fillets could propagate straight up into here and straight up into here. So I'm going to do that. They didn't translate very well going up here, so maybe I should go back in and make sure that they are included. There we go. We're going to make another fillet. Notice that there's a sharp edge right here, and that's not reflected in the actual part. So I'm going to make one edge there, make it 0.43, and that'll just smooth that out. Okay, on to some of the finer details. You'll notice we are missing the hole that goes right down the middle, and that's next. We'll go to the front plane, create a sketch, and make a rectangle. And again, it doesn't matter exactly where we put it. And just dimension off of our planes from here to here. Again, I measured these all before, and they're close enough for now. From here to here is, there we go. Okay, so we've got that sketch right in the middle there. Exit out, go to Extruded Cut, and I want to make sure you see this one. We can do through all both, and it'll go through all on both sides, and that's exactly what we were looking for. Next, we're going to fillet this hole, and although the fillets are going to be the same size, I'm going to do them separately because we might want to change them at some point. So I'm going to do this one, this one, this one, then that one. Also, once I do this, it will be easier for the other ones to propagate via tangent, so hit OK for those. Make another fillet of the same size, and I'll do that edge, that edge, that edge, and that edge. Notice how we had to do both top and bottom. It didn't propagate through this sharp edge, and that's exactly what's there in the actual product, is a sharp edge. So we had to put a couple more clicks in there, but it worked out nicely. Well, we are almost done, and we have a few more features to go. Next one will be to cut the hole that goes all the way through, and I'll sketch that on the right plane. Going to use a rectangle here, then a circle, like that. I'll put it right on that point. Then I'll now drag this circle over to here. Whoops, that's not what I wanted. I want to drag this corner over to the circle. Try to make the origin and this point line up vertically. Then trim off these entities. Dimension this to be 0.31. Oh, we want a diameter of 0.31. So what do we do here? We right click on this and go down to display as diameter. And I want this to be 0.31 diameter. That's better. Go from here to here. Make that 0.16. Uh-oh. Notice how this just moved over. It's not symmetric. So I gotta make that symmetric. There's a variety of ways of doing it. These center lines can come in handy in other ways too. So somehow that point got selected, so I'll have to redo this. Okay, now we can go symmetric. Got 16 there, and all that remains is to go from here down to here. Accept that and go with liters, maximum, double click 0.5. Are there more efficient ways of doing things? Yes, but at least we are getting this done and you're seeing why. Okay, so I have the sketch. I want to do something similar to what we did before, which is to make an extruded cut and make it through all both. Green check mark, and that is pretty much what we wanted. Now we are missing a notch up here where the moving jaw slides into, so we need to make that notch. So we're going to sketch. Oh, it looks like our feature tree is all messed up here. That could mean a couple of bad things, but the first thing it should make you do is save your work. At least I know I can get rid of it by doing that, but it does make one wonder a lot. Okay, so I'm going to use the front plane to do our sketch, and it's going to be a pretty simple one. Going to face that, and I'm going to change how we're viewing this so that we can see the cut that goes all the way through. Going to make sure I grab that last point of that cut, come up here, then come down here to the end of the round, then come back up here, making a simple triangle. This triangle only needs one dimension, going from down here up to this point. I get 1/4 inch, which is about right from my measurements. And then I'm going to show you another way of making a cut. So we're going to go to Features, Extruded Cut, and we're going to use that sketch, but instead of blind, I'm just going to go up to the surface. Don't have to worry about which dimension I need to find. I just want it to go back and forth between this surface and for the other direction, this surface. So I want it to go back and forth in between these two surfaces. So I don't have to worry about whether I change the dimension here or not. This little triangle cutout will go along with it. And so there it is. It cuts it right out. Alright, now the hole that goes here is 0.21 in diameter, and it is 0.68 down from here. So we're going to sketch on this plane right here. This makes the most sense here. And look straight at that sketch. Make a dimension of 0.21. Make sure that it is aligned right up with the origin. Hold the control key down, go here, vertically aligned on that. We could have also put it right on the front plane if we'd so desired. So I could click on front plane, click on that center point, and made it right on that plane. I would have done the same thing, but we need to go from this top face, or better yet, the top plane, down to the center point, and it's supposed to be 0.68 from up there. Oh, gotta select that, 0.68, and exit sketch. I'll click on that sketch, go to Features, Extruded Cut, and I want to go through all. Now through all both would do that. We don't want that. We just want to go through all in that direction. Oh man, I guess it didn't like my change. Right click on it, go back here. Oh, that's right. When you do through all both, it selects a direction 2. I just unclick that and we're all set. Okay. Last but not least, we have a tapped hole in here. And I wish I had been able to show you this a few more times, but this is a very helpful thing. This is called the hole wizard right here. You will see a variety of types of holes that you can use. Since I've used this one most recently, it's selected, but you can do counterbores and sinks and all sorts of things, and our hole specifications and all that stuff. We actually want to go to a number 1032. Number 10 is the size and 32 is the number of threads per inch. And you can even get custom sizing to show the different diameters and whatnot. And we're going to have it, the blind depth 0.47. Our thread is going to be 0.09 here. So this is the kind of hole that you're making, and there are many different options, and we're going to get it with the thread call out. Then you have to tell it where to put these things, and all you have to do are sketch some points. Now sometimes those points are annoying, but I'm going to select this face here. Now if you need a 3D sketch, you have to click 3D sketch right now, but don't do that. We're only putting one in. But if you need to put these holes on different planes, then click the 3D sketch now. Otherwise you pretty much have to go back and start over. So I'm going to click on this plane and I'm going to put points here. And all I need is 1 point. And if I look parallel to that, I want that point to be concentric with this circle, but we'll get there. So now I've got that point and it's there. I just need to make sure I get that point where it belongs. So right click here. Well, this sketch is the sketch of the hole, and it does this revolved cut right there. But this minus sign means that this point is not aligned with anything. So what we want to do is take that point and put it on an axis. So I'm going to go to View, Temporary Axes, and that point is still selected. I'm going to hold my Control key down, select this axis of this hole, go to Coincident, hit my green check mark, and now it's black, and it should be right down the middle. And they are wonderfully concentric. So I recommend using Hole Wizard when you need to make a slightly more complex hole. There's a great example here where we just did an extrude cut to get a simple cylindrical hole right through. But if you need anything with a counterbore or threads or anything like that, I recommend that you use Hole Wizard. Now notice a very important thing. You don't actually see the threads in here, but they show you what is called a cosmetic thread here. And there are a few purposes for that. First off, if you're just going to call out a thread, then that's enough for the machinist or the machine itself that's making the part. Number two, to make threads, either cut or placed on there, as we'll see in a couple of the following parts, the computer will actually do a huge series of tiny little cuts. What that does is it slows everything way, way down. So if we can achieve a single, easy to process feature that doesn't cost us a lot of time and energy in memory or video processing, then we may as well just have a called out thread rather than something that's cut. I will show you how to make some helical cuts, which are some threads, but this should be good enough. Let's look at it from this perspective and zoom in with our front plane, and you can see right in here that the threads go this deep, but it's just cosmetic. Again, you don't actually see the thread cuts. I really like using these section views. It can help you get a great idea of if you're actually making what you want to make. Okay, from here, I'm going to right click on a few things and hide them. Get rid of those temporary axes. Make this axis hidden. Make that point hidden. Plane 4 should be hidden. And we are now done with our crescent handle. In review, we started off this crescent handle trying to figure out where to put the planes and the origin. Seemed best to me to put the planes here for the reasons that this happens to be a place where we've got two major things that are going to connect with something else that happen to be at right angles. And much of the complex geometry is also associated with these. The handle down here, well, it had to be at an angle. Something had to be at an angle. I felt that the simpler stuff down here could be more easily modeled at an angle than the stuff up here. So chose that. Then we started off with this simple shape. Took a while to do some of the measurements and make sure that all came out, but it's fairly simple. Then we put a draft on it, learned how to do a draft, which can be very handy in many applications, including molding and casting. Put an important point down there. That was the center of this arc. Then we made a plane through that point up to this edge so that we could cut this surface to make it a little more curved rather than sharp, because it's more curved in real life. And then I mirrored it. Now there's another way of doing that cut. I will show you how to do that when we do the other jaw. It's a little bit simpler, possibly better, but it has its own problems. Then we made a series of planes and axes. So made a plane offset from the upper surface, an axis right where the top plane and the right plane meet at an angle to the top plane, and plane 4 is offset from that angled plane by 1.5. Then from there, made the entire handle in an extrusion with some interesting geometry. It was not all that challenging, but the key thing was that these two edges are not parallel, so we had to work with that and somehow make sure that this handle came straight out from that plane. Then we cut the details into both sides by doing one and mirroring the other side. And finally, we connected these two by making a loft using those sketches that we had made before. Finishing up the handle, we filleted the edges. We had to modify the fillet a little bit to make sure it captured all the edges on the loft. Then we made another fillet over here just because it seemed like it wasn't quite reflecting the reality of what I had measured. Then we made the slot for the worm gear, and we filleted that. Then we slotted a hole for the rack for the moving jaw and made another notch to accept that as well. Almost finally, we made the hole for the set screw, and then we made the tapped hole for the set screw. For this, we used just a simple cut, but for this, we used the hole wizard that gave us a lot of options. This is the hardest part of the crescent wrench handle, and I hope it helped. Notice that the diagram that I gave you may or may not have helped you, as there are a lot of dimensions that I did not include and some that I did include that may not have been mentioned in this video.